Hi, my name is Richard Potter. I'm from Harper Corded Software. I'm going to demonstrate M2SLink. With M2SLink, you can connect Mathematica to SAS. You can import any SAS dataset into your Mathematica notebook. You can export your Mathematica data back to a SAS dataset, and you can run any SAS program from within your Mathematica notebook. In addition, M2SLink has a unique interactive scatter plot which helps you explore your data. Well, thank you everyone for coming. I really appreciate seeing you people. My name is Richard Potter. I have a company called Harper Corded Software, and today I'm going to give you a demonstration of my product, which is called M2SLink. I'll skip the details about myself. Those are included in the notebook that you'll receive. But suffice it to say that I'm a developer. I worked at SAS Institute for 25 years. I retired at the end of 2018 and created my own company called Harper Corded. And the purpose of that was to create an add-on for Mathematica that I call M2SLink. M2SLink uses the Wolfram Symbolic Transfer Protocol, WSTP, to connect your Mathematica notebook to SAS. Using M2SLink, you can do several things. You can import any SAS data set or jump data table directly into your Mathematica or Wolfram notebook without having to use what are called SAS transport files. You can, when you import your data, any SAS formats that you have or user-defined formats are going to be automatically supported, and date time values will be automatically converted back and forth between the SAS 0 hour and the Wolfram 0 hour. In addition to import, you can also export Mathematica data back to a SAS dataset or to a jump data table. Now, not every type of list of Mathematica data can be exported back to a SAS data table. Your data list must conform to certain requirements that SAS imposes. SAS really only can recognize two fundamental data types, and that is character and numeric. So if you have a blob or a sound file or something of that nature, you're not going to be able to export data sets that contain variables of that type. In addition to import and export, M2SLink also allows you to run any SAS program from within your Mathematica notebook. So with these three features combined, essentially what happens is you can use your Mathematica or Wolfram notebook as an interface to SAS. So in addition to showing M2SLink's import and export and submit capabilities, I'm also going to show its interactive scatter plot, which is unique to M2SLink, and that'll be coming at the end of the demo. I will point out that right now, and probably for the foreseeable future, M2SLink only runs on Windows. In fact, it requires the 64-bit Windows operating system. It requires 64-bit Mathematica for Windows and some kind of 64-bit version of SAS for Windows. It's compatible with version 11 and version 12 of Mathematica, and it'll run with any 64-bit version of SAS for Windows like version 9. So the first thing we need to do is to actually load, or as the terminology goes, install the executable. So I clicked on the install function, the line that runs the install function, and that creates a link to my executable. Excuse me. And because I have a preference set in my preferences file for M2SLink, in virtue of running the install function, it automatically launches SAS for me. And by the way, when you terminate your Mathematica session, it will automatically terminate your SAS session for you. If you want to, you can manually launch SAS just by running M2S start SAS. Now, in addition to launching SAS, we're going to load a package that comes with M2SLink called M2SLink Utilities. What a big surprise. It contains a lot of helper functions for manipulating the data list that import returns, and it also contains the definition of the interactive scatter plot. So let's go ahead and import a data set from SAS. I'm going to run the M2S import function without any arguments. What that's going to do is it's going to bring up a file open dialog. This is one of the ways you can import your data from SAS into your notebook interactively using a standard Windows file open dialog. And I'm going to pick the staff data set, click open, and in a few seconds it brings in a list. It also opens up this data viewer. You can turn this off if you want to, but it does provide you with a perhaps more familiar view of the data in terms of a spreadsheet style presentation. The actual list that M2SLink, M2S import returns actually looks like this, and it contains 3 sublists. So let's just go through that. Let's look at the entire thing one at a time. The first sublist returned is table info. Basically tells you, okay, what was the path to this data set on disk? How many observations does it contain? How many variables? The second sublist is actually your metadata. It contains information about the variables in this data set. So you'll notice that one of the variables is named first, it's of type character, and it's, can take a maximum of 20 characters. In addition, you'll notice that some of these variables, for example, salary and hire date, have SAS-defined formats associated with them. So for example, the salary variable has the $10.2 format associated with it, which means that when SAS presents this value in a data grid, it's going to format it in a special way that's unique to SAS. Pardon me. Likewise, for the hire date, that's got a format of date 9. This is one big advantage of M2SLink versus using SAS transport files. Up until now, the only way you could really get your data into SAS was either export it from SAS into some kind of comma-separated value format, or use a SAS transport file, which essentially converts a SAS data set into a comma-separated value file. In the process, you lose all this metadata. You lose all this format information. And that's a big problem for most SAS users, because a lot of serious heavy lifting SAS users put a lot of effort and time and expense into creating formats for their data, because that contains a lot of metadata for them. So they don't want to lose that. And so this is, I think, one of the nicest things about M2SLink is now SAS users can get their data into Mathematica, take advantage of all the wondrous capabilities that Mathematica has to offer, and they don't have to lose anything. There's no degradation in terms of data transfer. Here is the third list. That's the final and third list provided by M2S import. This is the list of actual observations in a matrix form. And you'll notice that, as I mentioned, the hire date is formatted using a traditional SAS data format, and so is, the salary field, and so is the hire date. Now, you can get at the underlying numeric or date object that is associated with the formatted string that you see in this table quite easily. So for example, let's extract the Danforth obs. That's the second observation in the actual list of observations. And let's go ahead and get the 6th element out of that observation, which happens to be the hire date. So we get back a string that says 18 June 1976. We can get at the underlying date object value very easily by just indexing into level 2, and now we have the date object that corresponds to that hire date. So what this means is, if you're a SAS user, you can import your data into your SAS notebook, preserving all of your formats so you can see, okay, I'm familiar with hire dates expressed in that kind of a string, so okay, this looks good. Then you can access the underlying numerical data, the raw data, and play with that, use whatever Mathematica functions you want to analyze your data. So I mentioned that when you open up your, when you import your data, you get this data viewer, which is kind of a spreadsheet style presentation. You can color this in if you want to, so I just thought for the heck of it I'd make the background green, but I didn't in this I didn't set that preference for the demo, unfortunately. Now, because I don't have a lot of time, unfortunately, I'm not going to be able to demo the user-defined SAS formats. But suffice it to say that in addition to data formats like for currency and for dates, a SAS user can also define their own special formats. And in order to do that and to make use of those, it's pretty simple. You just tell M2SLink where is the SAS library located that contains these user-defined formats. That's what this line would do. And then when you import the data using M2S import, you use the format libs option and point to those SAS libraries. Perhaps I should back up a moment and explain that when you specify a SAS library, basically in Windows, a SAS library is simply the name of a directory. So you'll notice up here in this line, M2S assign libname, basically what I'm saying is, okay, here's the path to a certain directory, which happens to contain what are called SAS catalogs. These are files that contain definitions of user-defined formats. And I'm saying, please just name that directory more formats. So then I can refer to things that exist in that directory using the lib.member notation that SAS invented. So here I'm saying, okay, my format libraries are found in the library called samples, in the member called formats. And there's another one in the library called more formats, and the name of that member is gender. And when you run M2S import and specify those additional formats libraries, then you'll notice that this variable, the site variable, which formerly was just a 3-character code, let's see if I can go back and see that. Yeah, here it was like BR3, BR1. What the heck do those things mean? Well, those are formatted codes that are expanded using that user-defined format into these names of places. And likewise, gender, which previously in the original data set was just a single character code, has been expanded now. So SAS user formats are actually an extremely powerful tool. And what's nice is that with M2SLink, you can actually access those and retrieve them. Now I want to talk about exporting a SAS data set. In order to do that, I'm going to define a little list of SAS-compatible observations called physicist birthdays. This is a few of my favorite physicists. And I've associated with each one of them a certain record. So there's a last name, first name field, there's an age at death field, and a birth date field. And by the way, one thing I found interesting as I was creating this data set was I was always under the impression that according to history, Sir Isaac Newton was born on Christmas Day. I think that's kind of an apocryphal myth, because according to the latest Wikipedia information, that is not the case. He was actually born on the following year, January 4. So.
Because of the calendar change, where they went from Gregorian.
Oh.
England delayed the change for a long time because they were Church of England instead of
Okay.
Catholic.
Well, thank you for. I wondered why that, because I have like history of math books. I'm a big. Thank you. I'm a big, history of mathematics buff, and even in I think Men of Mathematics by Bell, one of the classics, it mentions he was born Christmas Day, and I thought, what's going on here? Okay, that makes sense. Thank you. Good. Well, anyway, whatever the case may be, in addition to specifying that list of observations, I also need to define another list which defines the metadata associated with this set of observations. So I'm creating a list, standard type mathematical list, that basically says, look, every observation in the data list that I'm going to export has these fields by these names with these types, and one of them has a format that I want you to use, date 9. So what this means is when I export this list of observations to a SAS data set, SAS will record the fact that whenever it presents this data in SAS, it should use the date 9 format to represent the date. So when I do that, once again, there are various ways you can export. In this case, since I'm not supplying a path or a lib.member as the target destination, I'm presented with a file save as style dialog, and now I could navigate to a directory and say, put it here. I will, in the interest of saving a little time, I will not do that. So you'll just have to take my word for it that this really does work. You're certainly welcome to test it for yourself. But if you were to do that, then you could, of course, run the import facility to bring it back and check it and make sure that it's right. Anyway, now the next thing I want to talk about is the feature of running a SAS program and importing the results. At this point in time, just about every SAS analytical procedure does provide some kind of output option that allows you to preserve the results of your, when you optimize a model, let's say, it'll allow you to preserve those results. Unfortunately, because these SAS procedures, or procs as they're known to the aficionado, were not all designed with the same care in mind, or there was no actual consistency applied, unfortunately. And so as a result, the same functionality is presented under different names. So for example, in one proc, you might have to use the keyword out to specify that you want output of a certain kind. In another proc, you might have to use a statement called output to do that. And in yet other procs, there might be another keyword that says, this is some output I want you to preserve. Now the thing that's really cool about SAS is that if you're familiar with running SAS, when you run SAS, you get this output window that shows you the results of your analysis, and it'll have table after table. You know, depending on how granular you want the results to be, you get all these tables that have all these things like your parameter estimates, your covariance matrix, etc. And every one of those things is actually some kind of a table in SAS. And therefore, if you know how to access it, you can grab it and import it into your Mathematica notebook. So all of the results, any analysis that you can perform in SAS, if it generates any kind of a table of results, and that's pretty much all they do. The only exceptions are those procedures that actually generate some kind of a PNG file, which is SAS's way of providing a plot. Except for those files, as long as it's a table of data, you can import that into M2S using M2SLink into your SAS dataset. So in this particular example, I'm just going to use the M2S submit function to submit a little bit of code. This is SAS code here in the double quotes. And what this little chunk of code says is, I want you to create a data set called HH. And that's all it does. And as a result, whenever you run M2S submit, unless you turn it off, you get this results viewer that basically tells you how do things go. And in this case, there's no output, but there is this log at the bottom that says, okay, everything worked fine. I created that data set. It has 16 observations. Next, I'm going to run this program, which invokes proc mixed. And what we're going to do here is we're going to use that HH data set that we just created, told SAS to create it. SAS is holding on to it. We're now going to call M2S submit again. We're going to give it a different snippet of SAS code. And in this case, we're going to tell it to run proc mixed using that data as input. And as output, we want it to generate the covariance, a covariance matrix that we're going to ask it to generate a table that captures the points in the likelihood surface. So there's a covariance parameter estimate that's generated in the final solution, and we're going to ask SAS to take that solution and create a table that sort of envelops that solution in a surface. So we can see what does the likelihood of the residual, log likelihood residual look like. So if I execute that program, once again, I get a results viewer, and this time I actually get back an output window that shows me, okay, these are all the tables that SAS produced running that model. And any one of these could be imported. Also, I can look down here. It's always a good idea to check the log. Did my program work? And it says, yep, convergence criteria were met. So it looks like the model successfully was optimized. So now I'm going to import this PARMS data set that I asked to be created, it's going to contain the data that represents that log likelihood surface. Comes back in this data viewer, like I said before. And then I can tell it, okay, these are the columns in a 3D plot that I'm interested in. And I'm using this helper function that M2SLink provides. If you call, for example, this function and you feed it the data set that contains your data and the names of the column of the variables that you are interested in, it will extract the columns of data that correspond to those variables and create this, little table, which I'm calling XYZ calls. And once I've got that data, I can then feed that to list plot 3D and say, okay, here are the labels I want on my 3 axes. And of course, now I've got this wonderful manipulable 3D plot. And there's nothing like this in SAS. The best thing that SAS can do, and this is just a very, very recent improvement in SAS, is you can actually generate plots in some procs, but they're all DOA, dead on arrival. There's, you can't click on them, you can't interact with them, you can't do anything except copy paste them because they're just PNG files and nothing more. Yeah, well, we could talk about that offline, but not everybody in SAS, in particular the primary owner, Dr. Jim Goodnight, wants you to get SAS. They're not really keen on you getting jump. But that's a long story. Anyway, final thing I want to show is, yes, 5 minutes to go. Great, thank you. I want to show you my interactive scatter plot, which I'm very proud of. This is a function that I've defined. It makes use of M2SLink functionality. So first I'm going to import the class data set. Now, up until now, we've been sort of brushing aside this data viewer and saying, well, you don't need to see it if you don't want. You can turn it off. But in this case, we want to leave it up because it's going to interact with our plot. And here's how that's going to go. So, I can just, So I've imported this data. I'm going to specify a list of names in which I'm interested, my x and y. Height is my x, weight is my y. And now I'm going to call the interactive scatterplot function. And it generates, a very familiar list plot. Maybe the markers are a little bit different from what you're used to. But what's unique about this plot is it's dynamically connected to that spreadsheet window. And what that means is if I want to explore this data, obviously I'm going to be drawn to this point because that's an outlier, it looks like. What if I click on it? What happens? Well, it becomes surrounded by this green circle indicating, okay, you've selected that point. And notice over in the data viewer, that row has been highlighted. So now I have a quick and easy way to click on any point in the scatter plot and figure out, okay, to which observation does that point belong? And the interactivity goes both ways. So I can, if I'm interested in Janet, I can click on Janet, and now the point for Janet gets highlighted in the interactive scatter plot. I can select a group of points if I'm interested in these points that kind of cluster together a little bit. I can select them, and they all become selected in the spreadsheet. Or I can go back here, select, let's say, discontiguous group of points, and they all become highlighted in the scatter plot. One of the things that I have I'm grateful for is when I demoed this, an earlier version of this, to some of the Wolfram people, they said, well, what happens if more than one observation maps to the same point in your scatter plot? How are you going to be able to tell the user that? And I thought about that, and I said, well, how about this? I don't know if this is by design or by accident, but it turns out in this sample data set that SAS provides us, there are 2 observations that actually have the exact same height and weight values. And so to indicate that there's more than one observation mapping to that, I put a little diamond around that point and highlight both of the observations. Now the last thing I want to show, I'll try to make this real quick, I'm sorry, I know I'm running over, is the fact that you can actually set markers on various points. so that you can you can visualize the difference. So I'm going to click in this column that automatically sorts the data based on sex. I'm going to highlight all the females. I'm going to right mouse click to bring up this pop-up context menu. I'm going to select a marker that looks like an asterisk, select red as the color, click OK, and now all those points in the scatter plot are now colored red with the asterisk symbol. Likewise, I'm going to do the same for all the males in this data set. I'm going to set a marker and color for all of those. Let's see, I'm going to give each one of them I'll give them the wolf from wolf, and I'll make them all blue. So this is a very cool way. Now I can instantly tell, okay, which of those points in the scatter plot belong to the men and which belong to the women. Well, thank you so much, everybody, for attending. I really appreciate your coming and seeing here. I'm very happy to announce that M2SLink is now available in the Wolfram store. Here is the URL if you're interested, or you can just Google Mathematica add-ons if you're interested in this. And I should also mention that, and here it is, a little snapshot, a screen capture of the store with my product. After I froze the code and gave Wolfram the installer, and this seems like the ways to happen this way, after you think you're all done and everything's been tested and you say, okay, take it, then you always discover a new bug. And it turned out there was this bug in the M2S interactive scatter plot. It only happens in version 12. So if you buy this product and you have problems with the interactive scatter plot, rest assured that a fix is forthcoming. Thank you very much. If anyone's interested, I have flyers if you would like to take home some information, a physical copy of the information, be my guest. And thanks again, everybody.